I have a question about the fluid, turning the fluids into meshes. That was a pretty cool trick. I was wondering if we could go back and do that again. And just see if there's see different ways to experiment with that. Like with the emitters in the fluid, and then turning the point cloud into a mesh. It's kind of like it's a cool form finding technique.
Yeah, there's not much to do unless you really play with the constraints. Yeah, but I'm going to work with nParticle. I'm going to introduce nParticle, which is another way of using fluid. So yeah, let me introduce that. Okay. So this fluid, yeah, it's just you create and change some resolutions, and it's really about adding constraints and forces, like field forces, like all of this. Okay. Yeah, the nParticle will be also fun to work with. Okay, let me just, yeah, I wanted to show you how to integrate this with your, with the 2D constraint, 2D fluid to, yeah. So maybe there is a way to also, like you can develop this into 3D fluid, yeah. So let's do the exercise now. So 2D fluid is same as the 3D fluid. It's just 2-dimensional. You can also work with that kind of nice geometry. Okay, you can change the resolution. You can add more forces and so on. And okay, but what do you do with those fluid lines? So there is a way to, so let's add another tab. There is a way to query the vector information from each resolution point of the fluid. So let's go ahead and just do that. Just few lines, not too many. So I'm going to set the resolution, and the resolution is getting the attribute from this fluid. So I'm going to say get attribute fluid 1. The name is fluid 1 and resolution. So by doing that, we are getting the vector of the resolution, which is 10, 10, 10 by default. So let's have a look. Control A. So the resolution size is 10, 10, 10 and 10 and 0.25. Okay. Okay, so I'm going to for loop. So X is 0. X is smaller than the resolutions X. If resolution is 10, it's going to go from 0 to 10. And then resolution will increase. Okay, so we have this parenthesis created. Nice. We're going to for loop again for Y. To close the parenthesis. Okay. So it's good that it generated the parentheses for me. The auto format in Mel is not very good. So I'm going to loop through Y. So we are going to have X and Y resolution looping through. Okay, and I'm going to select the fluid, select the fluid one, and I'm going to create a grid point vector using X and Y and 0. And why this turns like that? Okay. And vector vector arrow end is a get fluid attribute. Get fluid attribute and at velocity and x I and y I. This is the direction of the velocity on each resolution point. Don't worry, I'm going to show you what this means. Okay, so after that, we are going to get the direction. Direction point and say grid point plus arrow end. And then we are going to create a curve. X and Y and 0. Then a curve need 2 points. So this direction X, direction Y, and direction Z. K, 0, K is 1. Okay, so that's it. So if we run this now, it creates a curve according to each resolution point and pointing to the direction of the vector fluid. So, which is pretty interesting. You can also use this to create, like, for example, different curve. So, for example, a curve that the degree is 1, and for the first point is obviously 0, x, y, z, x, y, 0. And the endpoint can be also x, y, but we can use the magnitude of this. So let's use magnitude of this arrow end times some number. Yeah, and then these parameters. And let's delete all these lines and see what it gives us. So it should give us a shooting lines. It gives us undulating lines. So you can also use this to determine a box. So you can stack an array of boxes. Okay, we can do that. So similar to the previous geometry, we use polycube and we create a normal cube to start with. And their size to start with can be just 1. Default. Yeah, I think that's it. And then set attribute and scale C. You can use the magnitude. And then set attribute. So we need to move it up to the ground, so we can use the key to set their position and say X, X, Y, and half of this. So let's see what it gives us. So it's erroring, so there is something wrong. Scale C. I didn't close the parentheses. Yes, now you have this undulating geometry. So if you want to update that, you can just run this fluid again and run this again. Yeah, so there is also, I'm sure you can also use the attribute from the 3-dimensional fluid to get their point and then replace geometries as such. But this is quite straightforward. If you dig into the command help, I think it's very, if you just spend a little bit of time, it's easy to grasp. So I'm going to save this one called Mel file. It's going to save as a Mel file. Yeah, on desktop, I'm going to say fluid extruder. And this one, I'm going to say save it and say Mel basics. So you'll see everything that we scripted today here. Okay. And there are a little bit different ways of typing Mel script. So let's close this. Okay, and let's have a look at the nParticle. What are the differences? So nParticle is a particle. So it also has an emitter. If you create an emitter and run a particle, it does that. So the difference is that it doesn't, it has more like a visible particle compared to fluid, and it doesn't have to have a constraint, world constraint. So this also works with all these field solvers. So same as the fluid. So whenever you create an emitter or whenever you create an nParticle, it creates this thing called the nucleus. which is controlling the world physics. So in order to add any physical solver environment, you need to add it to the nucleus instead of the emitter or nParticle. Okay, so let's create some few of this, but it's using the gravity. So I'm going to go to the nucleus and turn off the gravity. Then it goes like a space, right? It just goes around like that. Okay, so what we can also do is you can change the way you emit. So it's directional, omni, and on surface, and curve, and blah, blah. Yeah, but we are going to use this. Okay, and we can also constrain how many of them are emitted by going to the emission attributes. And if you say maximum count is -1, meaning that you emit forever, ever, forever. Yeah, but if you constrain this to certain number, maybe like 500, it emits 500 and you stop. Yeah. So let's say, okay, maybe we accept like, for example, 3,000 for now. Okay. And then maybe 2,000. And then, yeah, and then we are going to use some solver. So nucleus and go to field solver, and let's add a turbulence. So, okay. Okay, it's still like there's very strong force to go to the ground. So let me add some drag force. So you need to, yeah, it's errors because we didn't select the nucleus. So the drag force, that's not very strong. You can change the magnitude. That was too strong. Okay. Something like that. Okay, I think you can obviously like work with all this field. Go to select the nucleus and add different. So try this Newton to create some drag force. That creates something really weird. I'm not sure I like it. Okay, let's say we are happy with that. Okay, so you can, there's two ways to generate trail. So let's use this one called mesh. So first we create a mesh, create mesh network, and click the nParticle and control select the mesh and say mesh and add trails to particles. Okay. And now this is adding trails for hundreds of tails. So we had 2,000 of them. So let's increase this to 500 trails and let's see if it covers. Okay, it gets for 500, but the rest of them didn't get it. But it looks okay. So let me just increase this a little bit, 800. And you can change the tail length and tail scale to just see, look around what parameter works better for you, so you can really play with it. So I think I would like this to be slightly longer. Okay, but yeah, let's say, let's just run a little bit more so it comes all the way out from the emitter. Okay. Okay, let's say I'm not very, very happy about this one, but let's say it's accepted. I'm going to control D and freeze it. So you can work with it somehow, but it's a really high resolution mesh. Yeah, which is still good because you can render, you can 3D print it, you can extrude it and so on. But if you wanna make some more like tweak, maybe sometimes you might find it that like NURBs curves will be very handy. So in order to draw instead of a mesh, polygon mesh, which is really high res and it's not malleable for any changes. If you are interested in making a NURBs curve, you need to add some script, and let's have a look how to do it. Yeah. So for that, I'm going to say, save this. There's no point to save it, right? So let's just save it, nParticle. Okay. I'm going to make a new scene. It's going to be the same process. I'm gonna do it fast. So nParticle, create an emitter. Yeah. And nucleus 0 gravity, nParticle, constrain it. And this time I'm going to do it very slowly. So I'm going to constrain it to 25 of them. So like that, because we don't want to crash the computer immediately, we can slowly boost it up. Okay, and obviously we want some turbulence. Yeah, and some drag force. Just a little bit. Okay, that's good enough. Yeah, so let's start to create some script per particle to draw a NURBs curve on top of it. So how do we do that? We need to go to per particle attribute. And here you can right click and go to create expression editor. And here it's similar to any other software. There is a expression that you can write for when it's created and when it's in runtime. So there are like a few different, but we are going to add something for this too. So this is an expression we are adding to all of the particles. But from this expression editor, these lines will apply to everything. So first of all, we are going to add a on creation. Make sure that it's on creation. We're going to say, we're going to declare a vector called position. And this will be an nParticle shape 1 position. And everybody, when you are scripting, especially in Mel, it doesn't give you any error warning. You have to be really, really careful with capital. It's case sensitive, and the spelling. So just watch out. Yeah, that's what we make a lot of mistakes there. So we are going to create a curve with a declare name for curve. We're going to call it curve dash and nParticle shape 1 particle ID I capital. I'm also just double checking always if my spelling is correct. Okay. And then I'm going to say curve, and I'm going to create the first point with position X, position Y, which is the particle's position, isn't it? So position Z, and apply that to this name. Name using this particle's ID. So if I have particle called particle 1, I will have curve 1 associated. Particle 2, curve 2, and so on. Okay, and let's check create, and let's watch this console to see if there's no error. Okay, let's say create. Okay, it said something wrong. That's great. So we can check if we're erroring or not. So I'm missing the $sign. Let's create. Now it's good. Okay. Now let's go to the runtime. And in runtime, we are going to add the position vector to the curve. So the curve will accumulate the position information. But we don't want to do that every frame. We are going to do it every few frames. But anyways, we have to still declare the position vector and particle. You can copy paste. Let's just do copy paste from here. So let's copy paste these two lines, Control C and Control V. And nParticle position and the associated curve. That's great. And then we are going to add the particle position as a curve control point. So by doing that, we use append P and position X, position $sign, position Y, and $sign, position C, and use the curve name. So which means using this append, I'm adding a new point to the existing curve. Okay, but I don't want to do this every frame. I'm gonna do it every other frame. So I'm gonna give some constraints by saying frame divided by 5 is a truncated number, and once these two number is same, it means it happens only after 5, every 5 frames. So obviously, if you want to change the interval bigger or smaller, you can change the number here on both sides. We are going to go back to 5. Okay, and then say create. So make sure if you make any changes, you just say edit. And it's good that there was no error. Okay, so I'm going to now go back to our scene and play. So there were a lot of curves generated, and for some reason, it doesn't show up, but it shows when I start to click on it. So it's just a visibility issue for my computer. I don't know if you have the issue, but that's just visibility issue for me. So if I want to run this again, you need to delete them and then run it again. Oh, it clashed. It clashed. But anyways, that was it. That was about the particle creating NURBs trail. Okay. Any question? I think that was it from what I wanted to cover today, but let me check my note. Yeah. Okay. Yeah. Yeah, I think that was it.